class. I know that some of you were having difficulties with some of these practice problems. I just wanted to talk about it a little bit and kind of go over it in class with you or outside of class, just so you can review this and get some help. So let's go into this problem really quickly here. Here we have two spherical objects. They have masses of 1.5 times 10 to the 5th kilograms and 8.5 times 10 squared kilograms. So I'm just going to go ahead and write that up here. I'm going to label these, okay? So this is going to be 8.5 times 10 squared kilograms, and this one is 1.5 times 10 to the 5th kilograms. All right, and let's see. See if I can highlight this, get it a little bit better for you guys. All right, and there we go. There we go. So that's where we started. All right, so what else do we know? We know that there's a distance of 2,500 meters. And we're asking to find what the gravitational attraction is between those two things. Okay, let's come back in here and let's fill out our distance. This is 2,500 meters. All right, so let's go ahead and plug these numbers into our little box down here. Our givens, what we know, and then what we need to know. So the mass for our first object is 1.5 times 10 to the 5th kilograms. And our second mass is 8.5 times 10 to the 2nd kilograms. And our distance is 2,500 meters. And I can write that in scientific notation. That equals 2.5 times 10 to the third meters. All right. And it's asking us what the force due to gravity is. And we, of course, don't know that. So we can just write a question mark here, but we do know that it is in Newton. So we'll just write our units right there. All right. So I filled out our box of what we know and what we don't know, our knowns and our unknowns. And I've drawn our picture out here. And now let's go ahead and set up our equation. Okay. Let me clear off some of this stuff right down here. There we go. Use this white. There we go. All right. So now we have a little bit more space to work. We have a cleaner picture. So we know that our equation is the force due to gravity equals the gravitational constant times mass 1 times mass 2, all divided by our distance between those two squared. So let's plug some of these in. Okay, let's do some substitution. Our force due to gravity equals G, and that is right over here, 6.67 times 10 to the negative 11th. And then look right here. We have Newton meters squared divided by kilograms. So we can write that like this. Newtons times meters squared divided by kilograms squared. We talked about those railroad tracks, so this is where they're going to come in handy. They're going to come in handy for us. So that's the first portion. What's the next part? Well, the next part we have our mass 1. And our mass 1 is 1.5 times 10 to the 5th kilograms. That's 1.5 times 10 to the 5th kilograms. And mass 2. Mass 2. We have 8.5 times 10 squared kilograms. And so now our units on top, we have newtons, meters squared, kilograms times kilograms. So that's essentially this. Newtons times meters squared times kilograms times kilograms. We can simplify this further. Kilograms and kilograms are the same units. And so we can simplify that. What is kilograms times kilograms? Well, it's just kilograms squared. So we can rewrite that. Newtons times meters squared times kilograms squared. All right, so our units on the top are all correct, right? Simplified, units on the top simplified. And that'll come in handy in just a moment when we come back to this. So what we've done so far is we've gone ahead and we've taken our gravity and multiplied it by our mass 1 and our mass 2. We've done that right here. And now all we have left to do is we have to take care of our distance squared. So what is our distance? It is 2,500 meters. And it doesn't matter where that goes essentially, as long as it's on the bottom somewhere. We can put it right here. 2,500 meters. We want to square that. And that is 6,250,000 meters squared. And I'm just going to simplify that right down here, put it in scientific notation, 6.25 times 10 to the 6th, and meters. But we're not quite done. Not quite done because we have this square, right? So it's meters squared. Looks like I'm running out of room right here. Let's see if I can move it. Oh, no, not that. Let's see if this is gonna, no, that just turns it. Goodness. It's too small for me to grab. There, what if there we go. All right, there we go. Meters squared. All right, so let's look at our units. We have our units on top. It's newtons meters squared times kilograms squared. And on the bottom we have, in this first box, we have our kilograms squared. And in this last box, we have our meters squared. So our units for the bottom is going to be kilograms squared per meter squared. And we want to make sure that our answer is going to be in newtons, because that is what force is measured in. It's in newtons. Remember, we came over here and we had, we're trying to figure out what the force is in newtons. So let's see if that works. All right, so we're just going to put our units here. Our units on top were newtons times meters squared times kilograms squared, and we got that up here. All right, remember we multiplied our newtons times our meters squared times our kilograms, and that gave us these units up here. So what is meters squared divided by meters squared? Well, it's just 1, so those cancel out. And what's kilograms squared divided by kilograms squared? Well, that's just 1. So all we're left with is this is 1, and this is 1, and this is 1, and this is 1. We have newtons times 1 times 1, which is just newtons. And then we have kilograms I'm sorry, not kilograms, that was canceled out. So we have 1 times 1, which is just 1. And anything over 1 is equal to itself. So our units have all canceled out, and all that we're left with is newtons. So we've set our problem up correctly, and we can go ahead and just do the math right now. Okay, so I'm going to go ahead and get rid of our proof right here. Go ahead and get rid of that, and let's just plug this into our calculator. All right, so I'm going to go ahead and do that. 6.67 times 10 to the negative 11th, or actually we don't even need to do that. We can go ahead and we can do this pretty simply right up here. Let's look at our exponents. Remember, when we are multiplying numbers together, when we're multiplying scientific notation numbers together, we have to first make sure that they're all on the same base. In this case, it's base 10, right? And then we just have to add all the exponents together. When we're multiplying, we add all of our exponents together. So that's negative 11 plus 5 plus 2. So we have negative 11 plus 7. What is that? Well, it's just negative 4. All right. So what do we do next? We have our exponent, right? 10 to the 4th, or 10 to the negative 4th. We just need to go ahead and multiply just the numbers together. So we have 6.67 times 1.5 times 8.5. That gives us 85 85.04, but we're only using 2 significant figures. So it's going to be 85 times 10 to the negative 4th. Well, that can be simplified. That can be rewritten in scientific notation, and it can be written as 8.5, right? We're moving the decimal place over 1 to the right, so we're adding on 1 exponent. We'll be adding on 1 exponent. Here, this looks like an 11. It should be a 4. So what is negative 4 plus 1? Negative 4 plus 1 is 3. And so we're left with 8.5 times 10 to the negative 3rd. And then let's do the bottom part. The bottom part, we have 6.25 times 10 to the 6th. We don't have any units on the bottom, but we're left with just newtons on top. So remember, when we're dividing two numbers in scientific notation, when we're dividing those numbers, what we'll do is we will look at the exponents, and instead of adding them, remember we added them when we multiplied them together, we're going to be subtracting them. So here we have negative 3, and down here we have 6, so we take negative 3 minus 6, and that gives us negative 9. So our answer is going to be written as something times 10 to the negative 9th newtons. All right, so for this part, we just have to take 8.5 and divide it by 6.2. Okay, 8.5 divided by 6.2. We're just looking at the first numbers there. And that gives us 1.37. But as you know, we started this problem with 2 significant figures. So our answer needs to be in 2 significant figures. So 1.37, it gets rounded. In this case, we want it to be in 2 significant figures. So we look at this 7, and 7 is closer to 10 than it is to 0. So we round this 3 up. So it becomes 1.4 times 10 to the negative 9th newtons. And that is the answer for our problem 2. If you have any questions or concerns, if you want to review some of these steps, go ahead, rewind the video. Shoot me an email if you're unsure, okay? And I will see you guys in class tomorrow. Have a great day. I talk to you later.